So here we have a question on dynamics on inclined planes. We set the question or the diagram up just the way that we would in any other. Apply and demonstrate all of the forces and then see what we can do. So we know that we had a particle of unknown mass, so we'll represent that as mg, and here are the parallel and perpendicular components of mg. mg cosine alpha, mg sine alpha. We have a reaction force. I'll just add the positive direction of movement. So friction's operating in this direction, and we know the coefficient of friction was 0.5 or a half. Okay, so we seem to have all of our forces represented. We were told that tan alpha equals 3/4. So using this triangle that we should be so familiar with by now, just quickly represent the 3/4 as the 3 for the opposite, 4 for the adjacent, 5 for the hypotenuse, which allows me to calculate sine alpha and cosine alpha. Okay, from there, just going to resolve. We'll start by resolving perpendicular to find the reaction force. So R must equal mg cosine alpha. There are no other forces acting in that direction. Cosine alpha is 4/5. The reaction force is 4/5 of mg. We're now going to head parallel to the plane and resolve forces in that direction. So we're looking for acceleration, which means we can make use of Newton's second and say that F equals ma. So forces in the positive direction, we have mg sine alpha. Subtract the friction, so subtract half of R. Now that should equal the mass, it being unknown, m, multiplied by the acceleration. Let's go ahead and substitute some things in here. Sine alpha is 3/5, and we know the reaction force is 4/5. Half of that is 2/5. 2/5 of mg equals ma. Cancel out those m's, rearrange for a, and we have an expression for the acceleration. Acceleration is 1/5 of g. To three significant figures, 1.96 meters per second squared. Moving on to part B. So we've been asked to find the distance that it will slide in 2 seconds. Well, this is a Suvat equation or Suvat question. So we'll set out our Suvat variables. I'm looking for displacement. Initial velocity is 0. Final velocity I don't know and I don't need. Acceleration of 1.96, and we're talking over time 2 seconds. Which formula should we use? S equals ut plus half at squared. So substituting in those values, we get that the displacement is half of 1.96 multiplied by 2 squared. And that ends up being 3.92 meters traveled in those first 2 seconds. Okay, so here we go again. So another dynamic particle on an inclined plane. Let's just make sure we get the diagram correct. So A and B are 10 meters apart. Incline of 25 degrees. Okay, and since it's a Suvat equation, let's just set out our variables and fill in what we know. So we know that it's 10 meters to cover. The initial velocity was 2. We don't know the final velocity, but we're looking for it. And we don't know or need the acceleration right now. And the time taken is 3.5 seconds. So just plugging those into an appropriate formula. Rearranging to make v the subject. We get a final velocity of 3.71 meters per second. So next, we're going to try and find the acceleration, filling in our variables again. 10 to unknown acceleration and a time of 3.5. So the appropriate equation, s equals ut plus half at squared. Substitute in the values. So rearrange and simplify to get a value for a. 0.49 meters per second squared. Okay. So now we know the acceleration, we can make use of a motion equation, Newton's second law, F equals ma. So I'm just going to model this situation again and try and pull out all the forces that will be useful for this motion equation. So we'll go ahead and we'll add the mass, 0.6 g, its parallel and perpendicular components, reaction force, and the friction. It's this coefficient of friction that we're looking for. So everything else we should actually have a value for. 0.6 g sine alpha, 0.6 g cosine alpha. Well, since we know the angle is 25, 0.6 g cosine 25 and 0.6 g sine 25. So let's resolve perpendicular to the plane to get an expression for r. R equals 0.6 g cosine 25. Into your calculator, and we get 5.33 newtons for that reaction force. Going again, but parallel to the plane. So here's where we want to use F equals ma. The positive direction is down the slope. So 0.6 g sine 25 minus the friction should equal mass 0.6 multiplied by the acceleration, which we had calculated before, 0.49. Okay, in all of this, we are trying to make mu the subject. So let me try and simplify. So a value for r, we have 5.33. And then once again, mass times acceleration. Some smart rearranging to make mu the subject, and we get an answer. And we get an answer of 0.411. Okay, so this time we have a force that is going to be applied to the particle, and it's not going to be applied parallel to the plane. So let's see what difference that will make. So a box of mass 2 kilograms. Here's our 25 Newton force. I'm going to break that force into its parallel and perpendicular components. Since the angle was 10, here we have 25 sine 10 and 25 cosine 10. Now friction's acting in the opposite direction, didn't have space, so I'll just draw it over here as 0.3 r. We'll have some components for the weight and the reaction force. 2g cosine 10 and 2g sine 10. Okay, so resolving parallel. So resolving perpendicular, we get r equals 2g cosine 10 plus 25 sine 10. So into the calculator, and that gets us 23.6. So reaction force of 23.6 newtons. Let's go ahead and resolve parallel to the plane. So this is F equals ma. We have 25 cosine 10 in the positive direction, minus 0.5 r, minus the parallel component of the weight, 2g sine 10. And that's going to equal the mass times the acceleration. Rearranging all of that, we get acceleration 7.06.